Hi, I'm Oluwa Kemi and this is question 21 Physics Jamb Physics 2018, which goes thus. From the statement above, the qualities of a good thermometer are. So let us observe the statement above. The first statement, high thermal capacity. For a high thermal capacity thermometer means that high amount of heat will be required to raise the temperature of the substance in the thermometer by 1 degree. Okay, so the thermometer will only work when the heat of the body is very high. So this is not a good quality of a good thermometer. Okay, the second statement, high sensitivity. A thermometer with a high sensitivity with a quality of high sensitivity means that even little amount of temperature difference can be detected and observed. Okay, so this is a good quality. All right, the third quality, easy readability. Of course, the thermometer, that is mostly the glass thermometer, should be eligible. Okay, the readings should be eligible. All right, good. So this is also a good quality. This is also a quality of a good thermometer. Then the fourth statement, accuracy over wide range of temperature. Of course, this is also needed for a good thermometer, whereby the thermometer can record a low temperature and also record a high temperature. Okay, so from the statement above, the qualities of the thermometer includes 2, 3 and 4. Okay, so the answer option D is the right answer. Thank you for watching. See you in the next video. Again, this is question 22 Jamb Physics 2018, which goes thus. A machine is used to lift a load of 20 Newton through a height of 10 meters. If the efficiency of the machine is 40%, how much work is done? We can find this out from the formula of the efficiency of the machine equal to the work output over work input times 100. Okay, so from the question we already have some of the values. Okay, for instance, the efficiency of the machine is 40%, so we have 40 equals to the work output, which is the force times distance, which we have in the question, is 20 times 10. Okay, to be divided by the work input, which is what we're looking for, the work done. Okay, so let's x represent that, then times 100. Okay, so if we simplify further, so and cross multiply at the same time, so we're going to have 40x on the left hand side, then on the right hand side 20 times 10 times 100 will give us 20,000. Okay, so we go ahead to divide both sides of the equation by 40 in order to find the work input x. So we start crossing out, then 40 in 20,000 will give us 500 joules. Okay, so that is the work input. So if we go to the answer option D is the right answer. Thank you for watching. See you in the next video. Again, this is question 23, Jamb Physics 2018, which goes thus: which of the following could be effectively used to reduce friction? Friction, as we know, is a force that is resisting the relative motion of solid surfaces, fluid layers sometimes, and also material elements sliding against each other. So a common way to effectively okay, reduce friction is by using lubricant such as oil, grease. Okay, alright, so let's take a look at the options. Option A says water. Water could also be used to reduce friction, but not as effective as oil or grease. Okay, so in this case, water is not the correct answer. Okay, option B, petrol. Petrol cannot be used to reduce friction. Okay, or probably effectively used to reduce friction. Alright, good. Likewise, kerosene cannot be used or cannot effectively reduce friction. Then option D, yes, grease is one of the common ways to effectively reduce friction. Alright, because it is a perfect lubricant. Alright, so the answer option D is the right answer. Thank you for watching. See you in the next video. This is question 24, Jamb Physics 2018, which goes thus: a copper wire was subjected to a tensile stress of 7.7 times 10 raised to power 7 Newton per meter square. Calculate the tensile strain of the wire. And this brings us to the formula for calculating the Young modulus, which is equal to the tensile stress over the tensile strain. Okay, and already we have the values given, some values given in the question. Like for the Young module, we have 1 times 1.1 times 10 raised to power 11, which is equal to the stress, which is also given, the value is given in the question, which is 7.7 times 10 raised to power 7. Okay, it is the value of the strain that we are asked to calculate. Alright, so by the time we cross multiply in order to look for the value of the strain, we're going to have 7.7 times 10 raised to power 7 to be divided by 1.1 times 10 raised to power 11. Okay, so if we divide 7.7 by 1.1, so let us use the calculator quickly. 7.7 divided by 1.1, so that gives us 7. So we have 7. Then for the 10 raised to power 7 divided by 10 raised to power 11, we'll be left with 10 raised to power, that is 7 divided by 10 raised to power 4, and which is also equal, which is same as 7 times 10 raised to power minus 4. Okay, so the Tensile strain is 7 times 10 raised to the power minus 4 Newton per meter square. So this is our final answer. So the answer option A is the right answer. Thank you for watching. See you in the next video. This is question 25, Jamb Physics 2018, which goes thus. An object weighs 22 kg in water and 30 kg in air. What is the upthrust exerted by the liquid on the object? So this brings us to the formula for finding the upthrust, which is equal to the weight in air minus weight in liquid. Okay, and so the weight in air, which is equal to mass times gravity, okay, minus the weight in liquid, which is also mass times the gravity in water. Okay, and this is going to be equal to the mass times gravity. The mass of the object in air is 30 times the gravity 10 minus the mass of the object in the water, which is 22 times the gravity 10. Okay, so now we have 30 times 10, that gives us 300, minus 22 times 10, which gives us 220, and this gives us the final answer, 80 Newton. So the upthrust is equal to 80 Newton. So the answer option B is the right answer. Thank you for watching. See you in the next video. Again, this is question 26, Jamb Physics 2018, which goes thus. A block of aluminium is heated electrically by a 30-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminium is. So this brings us to the formula. Heat supplied is equal to the heat gained. Alright, and the heat supplied is the power times time, okay, which is equal to the heat gain, and heat gain is MC times the change in temperature. Okay, and at this junction we need to note that MC is equal to heat capacity. Okay, so and the heat capacity is what we're looking for. All right, so we now have the heat capacity, MC, is equal to the PT over the change or rise in temperature. All right, so now we have the power which as given in the question, which is 30, okay, times the time it took, which is 5 minutes, and we have to convert the minutes to seconds, so we multiply by 60 to be divided by the temperature rise, which is 10. All right, so by the time we simplify further, 0 cancels 0, so 30 times 5 times 6, so this will give us 900 joules per Kelvin. Okay, good. So that is the heat capacity. So the answer option C is the right answer. Thank you for watching. See you in the next video. This is question 27, Physics Jamb 2018, which goes thus. A perfect emitter or absorber of radiant energy is A. We're given the following options to choose from. But first, let us go through some concepts. So objects that are good emitters are also good absorbers. Okay, and this is a law that is stated as or known as the Kirchhoff radiation law. Okay, so for a blackened surface is an excellent emitter as well as an excellent absorber. Okay, but if this same surface is silvered, it becomes a poor emitter and a poor absorber. So a black body is one that absorbs all the radiant energy that falls on it. Okay, good. So let's go back to the question. A perfect emitter or absorber of radiant energy, which happens that if we have a perfect emitter, it's also a perfect absorber. Okay, is A, white body? No. B, red body? No. C, conductor? No. D, black body? Yes. A black body is one that absorbs all the radiant energy that falls on it. So the answer option D is the right answer. Thank you for watching. See you in the next video. This is question 28, Jamb Physics 2018, which goes thus. The phenomenon that shows that increase in pressure lowers the melting point can be observed in A, sublimation. Sublimation is the transition of a substance directly from the solid state to the gas phase without passing through the intermediate liquid state. Okay, so this does not correspond with this phenomenon. All right, good. So now let's go to the next option, condensation. This is the process by which water vapor in the air change into liquid water. Okay, this also does not have anything to do with this phenomenon given in the question. Okay, so we go to the third option, coagulation. Coagulation, also known as clothing, is the process by which blood changes from liquid to a gel, forming blood clot. Okay, so this also does not correspond with this phenomenon given in the question. So now let us check the last option, regulation. This is a process of generation of melt water from ice, which is subject to high pressure or to higher pressure Okay, that is to say, the higher pressure of ice mass lowers, let me rewrite that, lowers the melting point and causes the ice to melt. Okay, so we can see that regulation is a phenomenon that shows that increase in pressure lowers the melting point. So the answer option D is the right answer. Thank you for watching. See you in the next video. This is question 29, Jamb Physics 2018, and the question goes thus. If the volume of a gas increases steadily as the temperature decreases at constant pressure, the gas obeys. So first, what the question is saying is that as the volume increases, the temperature decreases, which means that the volume is indirectly proportional to the temperature at constant pressure. Okay, let have a P. Alright, so let us now go to the options to see which one of this law correspond with this principle. Okay, so the first option, Graham's law. Okay, Graham's law states that the rate at which gas diffuse, okay, the rate at which gas diffuse is inversely proportional to the square root of their density. Okay, so this does not tally with this. Alright, so we go to the next law, which is Boyce law. Boyce law states that at constant temperature, the volume of a given mass of gas is inversely, okay, proportional to its pressure. Okay, remember, at constant temperature. Alright, so this also does not tally with this. Okay, what about the C option, pressure law? Pressure law, also known as Gay-Lussac's law, is one of the gas law which states that for a fixed mass of gas at constant volume, pressure is directly proportional to the absolute temperature. Remember, at constant volume. Okay, so this also does not correspond with this gas law. Okay, so let us try the last law, which is Charles law. And Charles law states that the volume of a gas is directly proportional to the temperature provided pressure is constant. Okay, so if we look at these four given laws, there is none that tallies with the law stated in the question. So none of these options are correct. Okay, thank you for watching. See you in the next video. This is question 30, Jamb Physics 2018, and the question goes thus. Steam burn is more severe than that of boiling water because, let us understand this fact, that steam will produce more severe burns than boiling water because steam has more heat energy than water due to its latent heat of vaporization. Okay, this latent heat of vaporization is the amount of heat required to convert unit mass of liquid into vapor state without change in temperature. Okay, so let's go back to the question. Steam burn is more severe than that of boiling water because A. Steam burn is independent of relative humidity. No. B. Steam possesses greater heat energy per unit mass. Exactly what we just said now. Alright, so the answer option B is the right answer. Thank you for watching. See you in the next video. Bye bye.